Hello, Wizards here. Day 18 of AOS 2024 has landed, so let's maybe not continue this intro anymore and just go straight there. If you know what AOS is, check out my first video, or just first link in the description, you're gonna learn absolutely everything. And now, let's go. We got this and 4 or 5 days left for Christmas. We're really close. Dirt on the mayor, the glitch needed more, but dirt was protected by a pesky locked door. But no need for panic, no need for dramatics, the glitch would get through with these game mechanics. Glitch was keen on uncovering Mayor Malware's deeds. Today, he was sure he would find something neat. He knew the mayor had an office downtown where he kept his dirty laundry, the big old clown. He approached the site silently, not knowing the door was closed, so ultimately, yeah. At the front of the door, Smart Lock awaited. Glitch smiled because he knew it could be subverted. But oh, big surprise. The lock was airy, a game controlled. A glitch, almost word Terry. If you are wondering how this came to Mayor Malware to be, Mayor Malware himself will explain it quickly. Technology gets broken every day, was his claim, but nobody knows how to hack a game. Will Glitch be able to pass through this door, or will end up with 0 at his core? We're gonna understand how to interact with executable API, how to modify internal APIs, and how to hack a game with the help of Frida. Even though pen testing is becoming increasingly popular, game hacking only makes up a small percentage of the largest cybersecurity field. With its 2023 revenue reaching approximately 1.9 billion, the game industry can easily attract attackers. They can do various malicious activities such as providing illegitimate ways to activate a game, providing bots to automate game actions, or misusing the game logic to simplify it. Therefore, hacking game can be pretty complex since it requires different skills including memory management, reverse engineering, and knowledge if the game runs online. Alright, so first are executables and libraries. The executable file of an application is generally understood as a standalone binary file containing the complicated code we want to run. While some applications contain all the code they need to run in their executables, many usually rely on external code libraries with the .so extension. Library files are collections of functions that many applications can reuse. Unlike applications, they can't be directly executed as they serve no purpose by themselves. For a library function to be run, an executable will need to call it. The main idea behind the library is to pack commonly used functions so developers don't need to re-implement them for every new application they develop. For example, imagine you're developing a game that requires adding 2 numbers together. Since mathematical functions are commonly used, you'd implement a library called libmaths to handle oral math functions, which could be called add. The function would take 2 arguments, x and y, and return the sum of both numbers. Note that application trusts the library to perform the requested operation correctly. From an attacker's standpoint, if we could somehow intercept the function calls from the executable to the library, we could alter the arguments sent over the return value. This would allow us to force the application to behave in strange ways. Frida is a powerful instrumentation tool that allows us to analyze, modify, and interact with running applications. How does it do that? Frida creates a thread in the target process. That thread will execute some bootstrap code that allows the interaction. This interaction, known as the agent, permits the injection of JS code controlling the application's behavior in real time. One of the most crucial functionalities of Frida is the interceptor. This functionality lets us alter internal functions and input or output to observe the behavior. In the example above, Frida would allow us to intercept and change the values of x and y the library would receive on the fly. It would also allow to change the returned sum value that is sent to executable. Let's take a look at the hypothetical example. In this, a number is simply printed to the console, hello 1111. What we will want to achieve is replacing the value of an arbitrary one, let's say 137. Before proceeding, we run Frida trace for the first time to create handlers for each library function used by the game. By editing the handler files, we can tell Frida what to do with an intercepted values of a function call. To have Frida create the handler files, you run the following: Frida trace -main -i. You'll now see the handler directory containing JS files for each function your application calls from the library. One such function will be called sayHello and have a corresponding handler at handlers.hello sayHello.js. allowing us to interact with the target application in real time. We don't need to understand what the file does just yet. We'll review this later in the task. Each handler will have two functions known as hooks since they are hooked into the function respectively before and after the function. On Origin, from this function, we're mainly interested in the args variable, an array of pointers parameter used by our target function. Pointer is just another student value. By the way, about pointers, if you're learning something low level and you don't get pointers, I can link some in the description or in the comments a cool GitHub repo where a guy explains how pointers work really quickly, and after reading just the first part of, if I recall correctly, 10, I understood pointers perfectly. So yeah, that's an amazing source. We don't need to understand what the file does just yet. We will review this later in the task. Each handler will have two functions known as hooks, since they are hooked into the function respectively before and after the function call. On Enter, from this function we are mainly interested in the args variable. Yeah, only if we are interested in the ret_val variable, which will contain pointer to the variable executed. We have pointers, not just variables, because we change any value, it has to be permanent, otherwise we modify the copy of the value, which will not be persistent. Returning to our objective, we want to set the parameter of 1337. To do so, we must replace the first argument of the args array with pointer variable containing 137. Frida has a function called point, which does exactly allocate some space for a variable and returns pointer. We also want to log the value to the original argument and have it to use function toInt31 to read the values with pointer. Alright. So the original argument. There's the original argument and replace the original value with 137. Yeah, it just says hello 137. Now that we better understand Frida's capabilities, we can return to Frida trace. We already have seen that generate JavaScript script to hook a specific function automatically. But how does it know which function is to be hooked? The parameter I tells Frida which library to hook, and it can filter using the wildcard, tracing all the functions in the libraries loaded. So we start the machine. We're having a split screen, so chill. And yeah. You can start the game by running the following command on the terminal. Just run TryHackMe. Exploring the game path around, you'll find the penguin asking for a pin. Terminate the previous game instance and execute the following Frida commands to intercept all the functions in the game library. So when some of the game logic is present, if you revisit the NPC, you can trigger the OTP function on the console displayed as setOTPI. Notice the output 20Z7 setOTPI indicates that setOTPI function is called during the NPC interaction. You can try intercepting it. Open your terminal and go to desktop, blah blah blah, and open the Visual Studio Code. At this point, you should be able to select the JavaScript file with the hook defined at the end of the setOTP. In case the integer will pass the parameter, which will likely send the OTP by passing it at the first argument. To get the parameter value, you can use the log function specifying the first elements of the array, args on the enter function. Log parameter args0 to string. Your JavaScript file should look something like this. Right? So just log this function and then the parameter. You should be able to log something similar to the standard trace. Then you'll need to enter the parameter as OTP. This value changes over time, so yours will be different. Try Unlock Me, a wishlist for billionaires. Exploring the new stage, you will find another penguin with a costly item named Rite of Pass. The game lets you turn coin by using the old PC on the field. By getting 1,000,000 coins, that way sounds tedious. You can again use free and so the function in charge of purchasing the item. This time will be more tricky than the previous one because the function buy item displayed as while purchase II has 3 letters after its name to indicate it was free integer parameters. You can log these values using the function for each parameter trying to buy something. Log parameter. Your JavaScript buy item should look like the following. You should be able to retrieve something similar. By simple inspection, we can determine the first parameter is the item ID, second is the price, the third is the player coins. If you manipulate the price and set to 0, you can buy any item you want. Alright, sounds interesting. So there's arguments 1 sets pointer to 0 to some pointer 0. Your JavaScript by item should look like this. Simple inspection, we can turn on the item ID. Second is the price. Alright. I don't understand what they mean by simple inspection, but yeah, we're gonna learn something here. The last stage is a bit more tricky because the output displayed by Frida is Z116 checked by matrix PKC, so it doesn't handle integers anymore, but strings, making it a bit more complex to debug. By selecting JavaScript file name this, you can add the following command code to the onEnter function as you did previously to debug the content of the parameter. Just add log check by matrix and the parameter. Memory read C string. This output doesn't seem very helpful. You may have to consider another way. You can log the return value of the function by adding the following log instruction. onLeave function. Return value is OXO. So the value returned is OXO, which may indicate that it's a boolean flag set to false, which will set to true. Yeah, it was gonna set 1 to true. What's the OTP flag? What's the billionaire item flag? And what's the... Alright, so let's go back to terminal and scroll back to actually solve this challenge. Will this finally launch? I'd be really glad. Alright, there it is. We have, I guess, terminals. List all. We should have there this. Where it was? It was cd desktop cd try unlock me, and we should have here a file called try unlock me. Are any handlers present? Alright, there are some handlers present, so I guess we don't have to run it anymore. Or at least... Oh yeah, because the OTP changes every time, so we will have to run it anyways. So yeah, let's try it. Alright, because we first going to capture... Alright, so we're gonna first capture this thing. Alright, so I guess we have the handlers first. That's right, let's go to handlers. Then to libgameco and run everything in code. Let's see what we have here. Right, the code is up. By the way, Kali Linux, when you run code, it doesn't run Visual Studio Code, but WSS code, if I recall correctly. Yeah. This one is set OTPI. And on enter, we should check the parameter, which being 20. Alright, so just add into log. So add in parameter. Right, so if from what I understand, what pretty much it does, it takes the argument of the variable and then outputs to our Frida output this parameter. Actually, that's a... If I can tell you something, this is a pretty cool way to understand all this stuff. Just try to explain out loud. That's why the rubber ducky method works the best. If you're coding, you will probably know what I'm talking about. Pretty much means that you need to exclamate your thoughts, and then the knowledge will stick to your mind a bit longer. Alright, we have this, we have all of that. Let's go back and try to... By the way, we can maybe trigger all of this stuff at once, so we're gonna set with purchase. This was the invalid purchase, and because we set the argument 1 was the pointer, we can just set here on enter args 1 equals not like this, but like this, it equals pointer to 0. Alright, so this is JS, so you can place this semicolon here or not. Let's save this as well. Not the site, but the page. And now let's invalidate the biometrics. And because it sends something out there, we're setting the red val to pointer 1, if I recall correctly. Not setting, but just red val dot replace pointer . Alright, we should have everything, but now let's go back to our terminal. Oh yeah, I forgot I have it running here. We go back to directories up, and when there is this Frida dash, what was this command? Let's go back. Frida, yeah, let's go with trace / try unlock me -I it's lib AOC game .so, yeah. Exclamation mark, let's add this here as well, this wildcard as well. Alright, so let's run this. Press space to continue. Let's maybe move it like this, so we can see. We go back to this little penguin, which will not a game. Aren't smart moves good enough? Mayor fears and can snock smart. The mayor fears anyone that's smarter than him. Three-factor authentication system. Yeah, the mayor from OTP. Do you have it? Alright, then you should get us. Oh yeah, there was plenty of stuff there. Oh, so we messed something up. I have blatantly messed something up when I see it. Loaded handler, library, loaded handler. Alright, reference error, arguments undefined in stack. Alright, let's go back to this biometrics pkcjs. Return val. What's wrong here? Let's see this biometric purchase. Return values. Following instruction will set its return value. Yeah, that's here, but we don't get any arguments. I guess that's what it should do. So yeah, let's go back also to this keycard PCA. I guess this one is for the next keycard, so let's not focus on this one. Args. Alright. Remember, it's always important to run everything as it should. Space, we go up here. What's wrong again? Loaded handler. At keycard, alright. We have this new biometrics with loading handlers, alright, that's good. Should come here and click space. Yeah, blah 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 blah. We know how it works. We read about it here. And the parameter is, you see we got a parameter here. That's our one-time password. 24303. Enter. Yeah, that's cool. You may now proceed. Alright, we can't copy this as always, so let's just maybe retype it. It's not something. It's the hash. DHM1 tough Password. First one is done. Amazing. Let's go back, and we now go to this weird store here. And the way I was playing this game kinda recalls me playing cracked emulator of Pokemon Red on my phone. The controls were pretty much the same. Just need to buy something with flag. Click return. But then because we set this value to 0, we can run it. Yeah, let's just as well THM credit card undeclined. That one works. So let's go back to the game, and maybe we can move on to the next part. By the way, we're set in -900, -99999, so like, yeah, it also works. Play your mouse, biometrics. His eyes doing, guys. Punch based. It has a very specific way of punching the keyboard that no one can replicate. You can gently put your hand on the keyboard, no need to get violent. Show me the keyboard. Please put your fist in the keyboard. You didn't punch the keyboard, your signature is correct. Mere malware would have hit the host query and possibly can't fool me. Me? I'm the mere malware. Yes, mere malware, vote for me please. Oh my bad. Welcome back, Mayor, we missed you. Here is the final flag, don't smash your keyboard. Wise advice, remember, don't smash your keyboard. Because new ones ain't cheap. And yeah, that's really about it. Thank you so much for watching. I hope you enjoyed this little walkthrough. If you like the content I'm doing here, leave a like and subscribe. Also check out other videos from this series if you hadn't managed to solve some other task. And yeah, that's really about it. See you tomorrow with another cool task. Cheers!